Hello and welcome to another episode of Modular in a Week. We are on the last part of day 6 where we're doing noise and random stuff. And today we are going to make the random gate by PHObos. And it is, as the name implies, random timed gates. So the time when a gate will be sent is the random effect in this module. It's a random timed module. So instead of, in the last episode we did a sample and hold, which did random control voltages, and this one do the random gates. So these two in conjunction makes up really chaotic music, which we'll hear in a bit. So before we go in and check the schematics and parts and panels and how to build this, I want to say thank you to my patrons who are supporting this episode and my content. So thank you Ryan LaRock, Mark Venti and Steve Cook. Now let's go and see where we found this information. This circuit was found, like many others I've built, on electromusic.com. Again, it's a very nice forum to visit if you have any thoughts of synth DIY, questions, or to share some of your designs. It's a very nice forum to be in, and people are mostly very kind there. So the circuit is, if I understand it correctly, there's a noise source up here, a noise generator, which produces white noise, which is then turned into, I'm guessing, some kind of filter. This potentiometer right here is the pot that I called probability in my on my front panel, because depending on how you turn it, it's more probable or not for a gate to happen. It then goes into a binary clock, and then you get a random out. I did add another jack here and a switch on this line here, so I can choose to have a external source instead of the noise in the circuit. So the circuit, there's nothing special. There's a 4.7 mega ohm resistor, which I choose to do because I didn't have that high number, so I choose to do it with standard values, 2.2 mega ohms plus another 2.2 mega ohm and a 330k resistor. Also the 51k resistor here, there's the 4.7 meg ohms, and here's the 51k. I use a 47k. If you have the correct values, of course use them, or else you can bypass them by doing that. Around $7 for this build, 32 part counts. I choose to make this intermediate because there are a few kVats that you can miss and a lot of cable that needs to be soldered between all the components. Other than that, the ripple carry binary counter, you can buy 10 of them for $1.50, but I choose to have a little bit higher prices here, so no one will feel that I lower the price to make them cheaper. And the front panel is, again, this was quite an early model, so this is quite wide. It is actually 5 HP. That could probably be compressed to 4 or even 3. So we have the probability knob, the LED that tells us when there's a gate, our random out, the noise out, and then a switch for internal or external source, which I chose to add primary as a troubleshooting thing, but I chose to keep it because you can do some interesting stuff with that as well, which I'll show you. So here's the final module in with the panel, and as I said, the only thing I added was the source in, and in the schematics that is technically just this line here from the source part into the random gate part. There's a switch there that just switches between the noise from the internal noise circuit or the external input. So that's the switch here. So that's the two added parts. And this is what it does. It does random gates according to the probability settings. And to show this, let's plug it into a VCA and plug a VCO into that. And with just one tone like this, it sounds a bit like Morse code. We can, if we want, we can spice this up by taking the gate, splitting that into the VCA and into the sample and hold. We can also take the source from the random gate because it has a noise out, and then we can take that CV output into the VCO. And now we have total randomness. If we instead take the source input and we take, for example, something from our colored noise module, this changes the probability. So in this case with blue noise, we can get really slow. We are not even halfway yet, and we are going really slow on the probability of a gate. Going down the line, white noise is extremely fast. Pink noise is not that fast, and red noise is somewhere in between. I don't know why it is like this. That's how it is. If we instead take a LFO into the random gate, I first, as an external source in, I first thought it would kind of follow the LFO. It doesn't really. It only triggers when there's a trig on the LFO, but so there's a bit more in tempo sync, but still it's random when in the when it will actually trigger. And the length of it is also decided somewhere in the random gate. And with this module, we are now done with day 6. If you've made all the modules in this day, then you will now have 3 white noise sources, which is good. Since this one also had a noise out, one in the white noise, one in the colored noise, which also had white, and one in this one. Plus you'll have digital noise. And if you find that the first white noise module you made was redundant, perhaps, then don't worry, we'll use that in some later videos making drums, for example. White noise is used in quite many drums. But we're getting ahead of ourselves. This modular in a week is soon finished. Next episode will be day 7, and we will make filters. And as you can see, there are already a few done, of course, and I have even more in the pipeline because I keep on finding really simple and really interesting filters that I want to make. And I know that a lot of you are waiting for filters, and well, filters is often one of those things that comes up very quickly when discussing modular synthesizers. What filters do you have? And I want this and that filter. The reason I put the filters last is I wanted to show that you can make fun and interesting stuff even without the filters. I don't know if that was a point to show. It was still interesting to put the filters last because that gives space and time to explore the other modules and what you can do with them before you start fiddling with the filters, which is quite usual. Enough rambling, I guess. Take care and see you in the next episode. Hope you liked, and subscribe and bell and do all that, and leave a comment below if you have any questions or comments. Of course, that's why it's called comments. And take care. Bye.